All right, so we need some definitions for paths. So, a path is closed. Closed being the word I'm trying to define. If you guys use this one?
Is that if you end up where you started?
Yeah. If its terminal point, oops. And initial point are
Same.
yeah, the same is probably equal seems awkward, right? The idea, of course, right, is you go out on some little jaunt and come back. Right, that's all it means. Keep in mind this thing allows like, so this is like your simplest idea, right? Some kind of circle. It also allows for you didn't go anywhere, right? This is a boring path. But of course, the terminal point and the initial point are the same, right? And then it also allows for things like this, where you kind of do these overlapping wanders, right?
So a golf course.
Put an orientation on that. That's probably backwards from the way I drew it, but whatever.
Yeah.
So you're allowed to kind of wander around. You can cross your own path and come back, that's fine. Other things are paths like this, where you go out and then back along the same thing. Right, this is also obviously a closed path. Cool. So keep in mind, they're not all just nice little loopy things, right? They could certainly do some strange.
So the second one, the one with random point out there, that was.
Yeah, so there's 4 of these here. There's one is sort of you go out around a loop. 2 is you just stay where you were. 3, you can chase around crossing your own path a couple of times. And 4, you could go out and then come back the same path. There's of course more kind of pathological things, but these are the ones that I think you'll probably care about. Cool. Keep in mind you're not allowed to do things like the path goes to infinity and then comes back from there.
Oh my God.
Right? They have to be finite time paths, so they have to stay in the space you're talking about. There are spaces in which that go out to infinity and come back thing would make sense, but the ones we operate in, it doesn't. The other thing we need is a path is simple.
Straight line.
No. That is linear if it's a straight line.
It's pretty simple.
Yeah, so what do I mean by simple?
Cross itself.
Yeah. So if it doesn't cross itself. So which of these are simple?
One, two.
Yeah,
1 and maybe 2?
If it's flat, maybe.
3 dimension.
Okay, so yeah, 3 might be in 3 dimensions, right? There's a way to construct a path that might look like that in 3 dimensions. But in 2, right, this thing's definitely not simple. 4 is
Nuts.
definitely not simple, right? Worse than crossing itself a finite number of times, this one crosses itself an infinite number of times. You guys see that? On 2, it depends on how long you take to get from that point back to itself. Does that make sense? Really what I mean by if it doesn't cross itself is doesn't cross itself. Maybe a better way to rephrase this would be to say, i.e., at 2 different times, it's in different places.
So you could say that a simple path would be a parametric function.
Yeah, the parameterization of a simple path, right, should be a one-to-one function.
That wouldn't by any chance include like helixes, right?
So
So they're
a
not
he-
crossing.
Yeah, so a helix in 3 dimensions is of course a simple path.
Okay.
Yeah.
And it'd be same thing with like an over and under, like
Yeah.
roadway would be a simple because they're not crossing. But compared to an intersection,
Yeah, so something like this,
yes.
right, in 3 dimensions where those actually go over and under, yeah, this is simple.
Okay.
Things like the figure 8 where they actually come together, right, the spot you would need a stop sign for with cars, that's not simple. Cool? That kind of makes sense?